Hello, chemistry students. This is lecture number 2 for Unit 8. It was for January 25th and 26th. And today we did not have a quiz in class. Instead, we worked on balancing equations together. We did like a table quiz where we actually kind of did it and then we checked our answers and stuff. So I'm going to reenact that. And then our new stuff is actually pretty short. But there will be, if you come back, a quiz on Wednesday for B and D block and a quiz for F block on Thursday over homeworks 1 and 2. So I'm going to use homework 1 as a way to review actually the balancing. So yes, you do have to do some translations, but let's go to some hardcore balancing ones. Okay, so I want to try this one right here. Let's put a line here. Remember, always put your oxygens last, but let's list our elements. So we got aluminums, irons, and oxygens. Remember, we want to have the same number of atoms of each of those on the left side of the reaction as on the right side. So I see 1 versus 2 for aluminum, so I cross that out. I see 2 irons versus 1 on this side. And oxygens are, interestingly, a 3 versus 3. Okay, let's see how we can make this work. Okay, so aluminum. Let's put a 2 in front of this one. And we get it to work. Let's put a 2 in front of the iron. That one can't be any easier. All right, let's try the next one. A couple easy ones to warm up with. So lithium and oxygen. 1 versus 2. 2 versus 1. So let's balance the lithium first. Sounds good. But then to balance the oxygen, I have to put a 2 over here. Remember, I can't change subscripts. Don't change the subscripts. So you have to actually multiply everything in the formula by the 2. So I'm trying to get O2. That's why I put a 2 in front here. But now I'm going to have 4 lithium. So I'll get the oxygen correct. Now my lithiums go up to 4. Which I can remedy here by putting a 4 here. Let's do some harder ones now. Okay. Next one. No, well, let's see which one. We're actually done already. I think I'm going to add some of my own here. I'm looking for a double displacement reaction in this mess. Let's see if I can find one. That's kind of one. I don't like that one though. That's single displacement. Okay. Let me do a double displacement. So let's take aluminum, 2 SO3. Let's add it to, by the way, there's a 3 there. Let's add it to magnesium phosphate. By the way, that's a 3 and that's a 2. And let's make over here aluminum phosphate, which is actually Al1PO4. Sorry, that's an A, by the way, somehow. Plus magnesium sulfite. By the way, is a 1 and a 1. Okay, so what we have is we count up stuff. Remember with doing reactions that have polyatomic ions, if they're the same on both sides, treat them as one atom actually. Treat them as one group. You don't have to separate them out into sulfurs and oxygens or phosphorus and oxygens. So I'm going to write out SO3 as a group and count that. PO4 as a group and count that. And I'm also going to look at, of course, magnesium. So 2 for aluminum and 1 on the other side. Sulfite, I have 3 versus 1. Phosphate, I have 2 versus 1. And magnesium, I have 3 versus 1. All right, so let's figure out if we can get this thing right. So aluminum, let's multiply this by 2. And when we do that, I actually get 2 birds with 1 stone. Let's multiply the magnesium by 3. Everything's balanced, actually. So I did this one basically to show you that if you have a double displacement and you have polyatomics, treat the polyatomics as one unit. Okay, so that was my lesson with that one. Let's try another one here. My next lesson is going to be something about CHs and Os. So I'm going to put C6H14 with a blank in front of it plus O2 gives us blank CO2 plus blank water. There we go. Okay, so we count our C's. Remember, H's go second to last and O's go last. because they're busy and they're complicated. So I have 6 carbons on this side. I have 1 on this side. I have 14 hydrogens on this side, but only 2 on this side. Oxygens, I have 2, but notice I have 3 here. 2, shoot, I'm so sorry. 2 for the CO2 and H2O, there's 1. So there's 3 there. So obviously we don't want to deal with the 2 versus 3. Let's see how it comes out when we correct the carbons and the hydrogens, where our oxygens will be. So let's put a 6 here. So that changes our oxygen to 13. Let's put a 7 here to go from 2 to 14. Let's change this to 14 now. Now what we have is 12 plus, we got 19. You might say, well, we're just as stuck as we were before. So here's an idea. Let's shoot for 38. What that means is you look for the least common multiple of 2 and 19, which means this side has to be multiplied by 19, the oxygens, and this side by 2. So let's do that. Let's put a 19 here, and yes, we get 38. Now where do we put my 2 on the other side? Oxygen's in 2 places, so I have to make my 6 a 12 and my 7 a 14. So I got to double all the oxygens, so I have to double my coefficients. So I will get my 38 here. But as you probably noticed, you just screwed up your carbon and hydrogen. So now you have 12 carbons and 28 hydrogens. So now you have to correct what you did. Well, let's get our carbons and hydrogens. Let's just put a 2 in front of here and we got it. So that's a good example of a tougher one. Let me try another one. So I'm going to take aluminum chlorate. And it's going to break down into aluminum chloride plus oxygen. That's a real reaction. So we count it up. We got aluminums. But now notice, you might say, well, ClO3, I'll count how many are on the left and right. I don't see it on the right, though. So I have to divide this up into atoms. And I'm sure bet we better put oxygen last. Like we always say, oxygen last. Hydrogen's last. If you have both of them, make hydrogen second to last, oxygen last. So 1 and 1 for the aluminum. 1, I'm sorry, there's a 3 here. My bad. Sorry, there's a 3 there. So 3 chlorines and 3 over here. Then I got 9 oxygens. 3 times 3. I got 2. So that's an interesting dilemma there. How are we going to get things to work? We're going to go for the least common multiple again. We're going to put 9 over here to make it 18. And we're going to put a 2 over here to get our oxygens also to 18. 3 times 3 times 2 equals 18. Well, in doing so, obviously, we now have a problem. We have 2 aluminums, and now we have 6 chlorines. See if we can correct that on the right side. So if we put a 2 here to get our aluminum back, it turns out our chlorides get back too. So we can do it. So 2, 2, 9. Okay, what else can we do? So we did a 2 versus 3. We did a combustion reaction. We did a double displacement. Let's try a single replacement. Let's see here. Ba plus aluminum chloride gives us barium chloride plus aluminum. Okay, let's try to balance this one. Barium, aluminum, and chlorine. 1 and 1. Aluminum is 1 and 1. But the chlorine is a 3 versus 2. I'm trying to give you scenarios that are hard so you know how to get your way out of them. So again, you have no choice but to multiply this side by 2, where the chlorine is, and this side by 3 to make them both get to 6 for chlorine. So I'll put a 2 here and a 3 here. So we both get to 6. That's awesome. But let's see what happens. So aluminum's now at 2, and barium is now on this side at 3. So let's clean up our act. Let's put a 3 over here to get our barium back. Let's put a 2 over here to get our aluminum back. So we got 3, 2, 3, 2. This is a 2, by the way. Cool. So anyway, those were some of the types of things we practiced, trying to see. Then one other one we'll try, just for kicks. We put C6H12O6, glucose, plus we add oxygen, which is your body. We produce CO2 and water. Oops. We got C, H's and O's to count. 6 versus 1. 12 versus 2. 2 oxygens versus 3. Okay, so we take care of our carbons. And now we have 13 oxygens. We take care of our hydrogens. And now we have, let me see, we have 18 oxygens. I think that's right. Oh, by the way, I got wrong number here. This is 8. There we go. 8 has to become 18, by the way. How are we going to do that? So again, 6 C's, 1 C, 12 H's, 2 H's there, and we just balanced that. So now we got an 8 versus 18. And you might say, well, I can't multiply anything by a whole number, 8, to get 18. 18 divided by 8 is not a whole number. We're supposed to use whole numbers for this. But do you notice up here, we could just take part of the oxygens and multiply it by something and leave one of them alone. In fact, we don't really want to put a number here and multiply our oxygens by 2 because that will screw up our carbons and hydrogens, which will in turn make us change this and change the oxygen, so we'll be chasing our tail. So let's say we'll keep our 6 oxygens, then we'll ask whatever we put in here, we call X, and make it 18. So we're not going to change them on the other side. So now, again, 6 oxygens from here, 2 times whatever we put in over here equals the 18 on the other side. So I get 2x equals 12. I can put a 6 in there. So anyway, we did a lot of stuff like that. But now our new lecture is actually pretty short. So for your quiz, and we'll look at homework 2 in a minute, we're going to learn types of reactions. We're going to be shown chemical equations of reactions. And we're going to basically label them as either synthesis reactions, decomposition reactions, single replacement, double replacement, or combustion. So I like to look at them in groups. So these two groups are very common to each other. So what you look for in synthesis and decomposition is on one side of the equation, there's only one chemical. By the way, these little lines are bonds. So here we have one chemical where molecule A and molecule B come together to make one molecule. So, by the way, it doesn't have to be 2. It could be 3. It could be 4. It could be 5. Many molecules, many chemicals become one chemical is a synthesis. So, for instance, in your body, when you make proteins out of hundreds of amino acids, that's a synthesis. That's also called anabolic reactions. When you digest food, which is full of big molecules, you take these big molecules and all the bonds between them and you break them. And that big molecule becomes many smaller molecules. That's the exact reverse of synthesis. So when you see a reaction that has one chemical on either side, it's either synthesis or decomposition. The rest of these, you don't see any of these next guys, which I didn't label. Let me put down this one, by the way. It's C question mark, H question mark, plus CO2 equals, plus O2 equals CO2 plus water. So none of the reactions down here do you have one chemical on either side. So if you don't see one chemical on either side, you're going to look for the next ones. First one I want you to cross out, and let me write this over again, is combustion. Combustion is very specific. You have to have some type of a carbon-hydrogen compound. That means C with a subscript and H with some subscript. Plus you burn it, which is O2, and you make CO2 and water. If it's not that, it's not combustion. So if you have, again, you see on this one that you have 2 substances on either side. Same thing here, you got substances. What I want you to key in on is if you don't see your CHs, you're one of these 2, of course. These little balls here are elements. So what you see is on one side of the equation, you see a compound. Remember, a compound's more than one type of atom bonded together, plus one type of element, a lot of times a 1Z. And then now that element becomes part of that compound, and a new element leaves. Notice it's called single replacement. A single element replaces another single element in a compound. So you see elements in each side. Whereas a double replacement, you don't see any elements. You see compound, compound equals new compound and compound. But what happens is two elements switch spots, or two groups of elements switch spots. So the best thing we can do is let's go to a little bit more. So many become one is synthesis. So if you have one compound or one chemical on the product side, it's synthesis. No other reactions we're going through are that. If you have one compound or one chemical on the left side, the reactant side, you're decomposition. No ifs, ands, or buts. Single replacement. Let's look at this a little bit more closely. So we got an element, this is a guy, and a new element leaving. Okay, but these are compounds. They have more than one element bonded together. So let's look at some examples of this. So here's an element, zinc by itself. Now we got a compound, copper 2 chloride, but now the zinc takes place of the copper, and the copper, which used to be with the date, goes home alone. Same thing with the other one. So anyway, we're looking for then elements with compounds, and then a new compound with a new element leaving. So element on either side, but different elements. Whereas double displacement, you don't see any elements. You see two things on the left, two things on the right. But then you look at it more closely and you're like, oh, sodium is with chlorine. Now sodium's with fluorine. Silver was with fluorine, but now it's with chlorine. What really happened is that this guy swapped with this guy and bonded with a new person. So it's a double switch. There's two couples and they switch dates. So here's an example. A and B is barium and chloride. C and D is magnesium sulfate. Barium and magnesium switch places. So now we got barium sulfate and magnesium chloride. Okay, combustion, as we said, hydrocarbons plus an O2, CO2, and water. What we'll do with that later is balance those. So let's go back to a test now, what you would see on your homework and also on your quiz. Let's look through these first and look for synthesis. That means there's only one compound or one chemical on the right. Got it? Here's one. And that's it. So we got synthesis for these guys. Let's look for decomposition. One chemical on the left. Here's one. And here's one. So this is decomposition. Okay, so all the other ones can't be either of these because we looked for them. Let's look for combustion. That's a CH something, C something, H something, plus O2, CO2, and water. There it is. Right down here, combustion. Now we're down to single and double displacement. So single displacement, we have elements kicking out an element that's in a compound. I see elements here. Element comes in, takes the place, and a new element comes out. That's single displacement. There are single elements. Okay, let's look over here. A single element, a compound, and a new element coming off. That's also single displacement. Finally, down here, we got compound, 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 compound. But we see that the K is now with a different partner, and PB is with a different partner, so this is a double swap. Notice that the double displacement does not have any elements. Double displace. So that's actually what we did. We had a lot of time for people to do homework 2, finish up homework 1. We had about 30 minutes or so of that. So if you think the lecture short, it's about right in the fact of what we did in class. So anyway, that is it for lecture 2 for Monday and Tuesday of January 25th and 22nd for Unit 8.